In the previous video, we explained the logical architecture of TDengine 3.0. Unlike version 2, the newest version adds compute node and stream compute nodes. This video gives an in-depth introduction to the qnode in TDengine. TDengine does not automatically create qnodes on startup. You can create qnodes as necessary for separation of storage and compute resources. Each D node can contain only one qnode. If a qnode is created on a D node whose support vnodes parameter is not 0, a vnode and qnode may coexist on the D node. Each D node can have a maximum of one vnode, one qnode, and one M node. However, you can configure your cluster so that vnodes, qnodes, and M nodes are always located on separate D nodes. If you set support vnodes to 0 for a D node, you can then decide whether to deploy an M node or a qnode on it. In this way, you can physically separate virtual node types. The show qnode statement displays all qnodes in the cluster, including the ID and the D node on which they are located. So when do you need to create a qnode? There are several typical scenarios. 1. When queries are affecting the write stability of the vnode. 2. When the compute resources on a vnode are insufficient, for example when there are a lot of long, slow, and concurrent queries in the system. 3. When you need to dynamically scale compute resources up and down. TDengine provides a variety of query processing functions for tables and supertables. In addition to common aggregate queries, TDengine also provides windowed queries and statistical aggregation functions for time series data. To process a query in TDengine, the client, vnode, qnode, and M node all work together. A complex aggregate query on a supertable may need multiple vnodes and multiple qnodes to divide the query and computing tasks between them. Let's take a look at the basic query process after the introduction of the qnode. A query begins when you enter a SQL statement, and the overall processing flow of TDengine looks like this. 1. The TDengine client driver, tausc, parses the SQL statement and generates an abstract syntax tree. It then checks and verifies the AST according to the metadata. During this stage, the metadata management module in tausc catalog requests the metadata of the database and table involved from the M node and V node. 2. After the verification is complete, tausc generates a distributed query plan and optimizes the plan. 3. tausc schedules tasks according to the configured query policy. A query subtask may be scheduled to a vnode or qnode based on data affinity or system load. Note that the vnode and qnode are both logical execution units. tausc first sends the task to the physical data node. 4. When a D node receives a query request, it identifies the vnode or qnode assigned to the request and forwards the request to the appropriate query execution queue. 5. The query execution thread of the vnode or qnode establishes the fundamental query execution context, executes the query, and notifies the client once it begins to obtain results. 6. tausc then initiates next-level query tasks if necessary, or otherwise simply obtains the results. This is the process by which a query is executed in TDengine and an overview of the function of the qnode. If you'd like to know more about TDengine, you're welcome to download the source code from our GitHub repo and visit our official website at tdengine.com.